Yeah, good evening, everybody. Mr. Timmy and Mr. Doubles. And I think Stephen is also there. Another person might be around. So today, for our class today, we'll be taking C functions in C. And I've just made a very quick outline of what I would like to just, if there's time, what I can go throughout today. So first things first, we're looking at what is a function in C. Then as a sub-topic under that, we will look at why we use functions and common functions in C. Then the second point, looking at how to use functions. Also looking at the stack and heap. We'll get to that, stack and heap, and then we'll look at implementations of some simple functions. We'll just do some simple exercises and that. And then lastly, we'll look about the importance of functions. So let me just go to I want to use an online compiler. I don't want to, my Visual Studio, I don't want to mess up my project up. I'll just go back here. So for today, we're looking at them functions. What is a function in C? We can argue that functions are like one of the most important concepts of a programming language, especially a programming language like C, because C, as everybody knows, is a procedural language. So when I say it's a procedural language, things are done like by procedure. It's like do A, after you do A, do B, after you do B, do C, after you do C, do D. So C is a compiled language, but the compilation process is line by line. So when the compiler starts working, for example, now, if I do something like print F hello ALX students, or not say let me say ALX engineers. So let's go to add a new line after doing everything. And I run this.
Okay, so Ebere, we can only see, we can't see what you're doing. We can only see the notepad. We can only see your notepad. I don't know.
You can see my notepad. Okay, sorry. Let me see. Let me go to share this class. I think I'm sharing this. Okay. Can you see this now?
Yes, we can. Absolutely.
Yeah, okay. Yeah, you can see it now. Yeah. Sorry for that. No so let us say this is simple. Everybody is like, this is a introductory course to C. So I'm using a online C compiler. I don't want to use my Visual Studio because we'll manage it just for learning purposes anyway. So if I run this now to print hello ALX engineers, so you can see that in our, this is the comment, we don't need this comment. So the way C starts is the compilation process will start with this. To look at this is a preprocessor. We all know that. To evaluate this, after evaluate this, it goes to the now. If you look at int main, this is what they call the entry point in our program, and this is the main function of our program. Because the way C is designed as a procedural language. So this is the main function of our program. So this is the first function of our program that the compiler sees. So the compiler starts from int main and starts executing from int main, then anything inside int main to not execute. So take for example, printf here, printf hello ALX engineers is also a function. What this function does is prints this hello ALX engineers. It prints it to standard out, to std out. Let me just add comments here. So print f function That's prints to ST out. So for now, we don't need to know what STD out is. It's an advanced concept, but just for now, just assume that this printf, anything that you put in printf, be printed to your console or your standard out, your standard outputs. It's called standard outputs because back in the days when they were developing C, there was something like a monitor. So that's to call what is to print to them a standard output. It could be a sheet of paper, it could be a network, it could be anything. So it just prints. So printf is a function that prints whatever you put inside this parenthesis, whatever you put inside, it will print it out to std out. So that is so now int main, as I said before, is the main function of our program. This is the first function for our program that gets called. Before printf can be called, int main itself is called. Int main is called. So this is very important, and according to C standard, if you have gone through any of the PDF, the PDF that I think Jeremy posted some PDF on the group, some PDF on C programming language. You always see that they tell us to always declare main as int. I should not do this. You should not, for example, you should not do void. Some old textbook that will say you should do void, but this is actually wrong. The correct way to do it is int main, because I'm returning 0, and 0 is an integer. So let me go back to my notes pad. So that's just an overview of so why do we use functions now in C? So I'm looking at why do we use functions in C? So let's take for example now, let's go back to my, take for example now, I want to print different to print names of people, about to print names of everybody on this on the group chat. So I'll start doing you see, it does not make sense for me to start doing print f. We'll say print Prince Jerry. That's in caps lock. Then I'll now do again print f. Print Prince Jeremy. And so on, print f the rest people. I can actually just write a simple, function. Let me see, I can just write a print everybody. I'm just doing just print a simple, maybe a hypothetical function in this case. And I'll just say print everybody. Print everybody in C programming course. So let us say that this function, for example, is I've not yet defined this function. Just say it's just a sample function. I'll just explain before I go into coding. So I cannot say something like this. One by one. I just do a function. I will just print everybody once. I will just get everybody name and print it once. So functions help us to separate code, understand the first separation of concern, to separate our code, to make our code more understandable when we are working as software engineers. So too much talks. Let me just give an example let me just say, for example, let's say I want to do a simple function now that adds 2 numbers. Let's just say a function that adds 2 numbers. So this is how we do it now. The way of going a function, the first thing we have to do before we can do a function is to get a function name and a function type. So for example, add two numbers. Let us call the function name addition. Let's call it addition. So this is the function name addition, and the type, let us call it int, or let us call it float. Call it float, so I can add the decimal numbers. Add the decimal. So let us call it float. We use float for here. So we use float, and let's say this function that we are defining is what I can add two numbers. So these two numbers are going to be of float type also. Let us call them num1 and float 2. Then we'll do I will do return sum of nums. So this is what we call a function prototype. You see, I've not done anything. I just defined what this function does. Let us understand step by step. Function. The name of the function is addition. The name of the function is addition. Every function must have a function name. So in this case, we call it addition because we want a function that adds two numbers. So to take any two numbers, them and give us their results. So I use float. You can use int, or to make it simple, we make it int to avoid the confusion. To those people that are not really on that, let me make it int to avoid any unnecessary confusion. Make it int. So let us say num1 and int num2. So they are the two numbers we want to add. So as you can see, I've not put any number. These are just variables as for now. I've not put any number. They can be 100, they can be 200, they can be 1000, they can be any integer number. So for now, I've just left them like that. So I've open braces now. Let us now define what this function. Now I can return sum of nums. What is the importance of this return statement? Why am I adding this return statement? For those people that might be looking at it. Now, if you look at your int main, you also see that your int main has return 0. Does this int addition have return sum of nums? We want to return sum of nums because anytime we add this variables that are here, they call the arguments. They call these arguments, this num1 and num2. Num1, let me comment this. Num1 and num2 are function arguments. So we call these things arguments. Num1 and num2, the arguments, they're like what we're going to pass. See that I've not defined them, I've not put a number there, but later on we can put any number we want, 1,000, any number, 1 million, any number we want, we can put them there and we'll do. So this return sum of nums is what this function is going to return. This addition is what is going to return. So let us not too much. Let us not say sum of nums is equals to num1 plus num2 Betty style. Let us do it like this. So sum of nums is equals to num1 plus num2. So what I'm saying is that this variable I'm going to return is going to be the result of the addition of 1 and 2 of num1 and num2. So let me just run that. So you can see that it's not print anything here, but it's running just fine. But since I've not made any calls to this function, so now come to my int main and now let me now call let me now say something like int a and int b. Can I say maybe let me say int a equals 10, b is equals 5. And now say addition. Let's do let me get rid of this line. Let me make this easier, simpler before I go to the harder part. So let me break down this function addition I've made there. This addition to take these numbers are called in normal. So in this place, I have put them 5 and 10 to replace num1 and num2. So num2 here is 10 and num1 here is 5. So it will now add these two numbers, add 10 plus 5, and it should now print results. Let us just run that and make sure there are no errors in my program. So I can see the output is the addition of 5 and 10 is 10, just as we expected. So we can also put let us put another number. Let us put 20 and let's put minus 10. Should give us a 10. Let's run that. So let me call it this. Minus 10. So the addition of 20 and minus 10 is 10. So you can see now that as we have defined this function addition that used to add any two numbers. We don't need to write a separate. We can just call this function at any time. We can just call this addition function at any time. I'm putting two numbers there. You can put 7 and 1, and we can just use this as it is. This addition to always add the two numbers there and give us the answer. So we can also do something similar to subtraction. Just call and that. Just write and that function. Other one subtraction. So did you remember the process of declaring a function? To declare a function, let me just put it here. To declare a function, this is the format we follow. Return type function name parenthesis function arguments. So things like args. You always see this. Maybe if people are watching, you always see this args in maybe your PDF. You see it's just short form of arguments. So function argument args. Can be how many arguments to need for functions. It doesn't matter. Function args can be 2, can be 3, can be depending on the function. Can be 1. Then body of function and then return results. Always ensure to put return results. So this is how we declare a function. The return type here could be int. So the return our result is, if our result is an integer, we use int. If it's a floating type, we use float. If it's a character, we use char. So it depends on what we want the function to return as a result. As we determine our return type, the function name. So the function name, we also use a name to refer to. So if I'm doing the function that can add 2 numbers, I just call that addition. If I'm doing subtraction, I'll call it subtraction. If I'm doing division, I'll call it division. If you say anything that you want our function name, then the arguments. These are the arguments here simply means the variables that our function will use to work that will appear in this body of the function. That is just the function arguments. It's not, every second they just like to keep the grammar. There's nothing big about the grammar. So that is that, and then the body of the function. So as we have seen in this my demo function. I've called int addition the arguments 2 numbers, int num and int 2, and the return statement here. Now there's also a catch in C. Anytime we declare a function as void, if we use void and declare a function, you cannot have a return type. If you declare a function as void, you cannot have a return type. If you put return something is to give you error. For example, let me try and compile this and to show me an error. You can see return some void function arguments. You can see void invalid use of void expression. You can see this show me one error and a warning. Return with a value in function returning void. So anytime you declare a function as void, you cannot say return something. You have to repeat the statement for it to compile and run it again. So as you see, that it's because of this let's move that. You can see invalid use of void expression. So any as void, you cannot use something. So now you ask yourself, what is the point of declaring a function as void? If you want to use as printing, for example, one may want to just print something, be void. Print add. Let me say So I just want to do a simple F hello ALX student. We just do the simple print like this. Then I can declare this as void because I'm not returning anything. I'm just printing to the screen. I'm not returning anything. I'm just printing. That's all I'm doing. I'm not returning any. I'm not doing any calculation per se. I'm just returning anything. So in this case, the program will just compile just fine. But that one is not. Let us look at more interesting ones. Void functions for now are not interesting. We don't need to. We don't need void this thing. You need functions that can do something. So, for example, let us now go to the let us now go to B. So common functions we have seen so far. We have seen printf. We have seen puts. Most of us will have used in our daily exercises. The assignments that have been given to us. We have used printf. Those are functions we have used puts. We might have not used power. This is the power function, and this is the square root function. This power function, what it does is it gives you the power of a number. So for example, if I want to do 10 raised to the power of 100, I will use this power function to do it. If I want to do square root of a number, I will use the square root function to do it. Let us look at this square root function, for example. Let's look at the square root function, for example. Now, keep in mind that if you want to use the square root function in C, you have to hashtag include maths.h. The maths.h is where the mathematical function libraries they are declared in. So this is how we can use the square root function. If not, if we try to use the square root function to get first errors, let me know if let us say sign number. Just call it 25. Let us now say so use square root function is square root 25. Let's put this on the side. So let's do this. Yeah. So what I've done, let us call this. I've just called this number 25. I want to get the square root of 25. So this sqrt is a function that is defined in this. Anytime math h include this library, this is a header file. This is a library. See? It comes to a compiler. So this function, the people that design the compiler, they have already written this function in this library. So anytime you type this, you can get the square root of your number as long as you include this library. So I can say print f percent u, since I will call it as unsigned. Unsigned, so I'm using percent, so I'm not using percent d. Percent u slash end, add new line, comma, square root of number. So what this you do now, it will, this number 25, this function square root of a number, sqrt 25 will give me the square root of 25. So let us run that. Hopefully everything will run fine. So that is it. So the square root of 25 is 5. So yeah, also I can ignore this and do this. I can say print f enter a number. I can say scan f So let us just like this so that we can enter any number, square root number. So what is this program will do that we can put with user, we can input any number we want to input any number, and this function sqrt square root of a number will always print the square root of that number. So let us run and see if everything. So we put 4. So we can see 8 and our program run just fine. So the importance of functions, can see that if we had done this the long way, then every time I want to get square root of a number, we ourselves will have to calculate how do you calculate the square root of a number. So maybe we have to use Taylor series to do that, or any other series, mathematics to do that. But yeah, you all we just have to do is do sqrt number, and we can reuse this code. So we can reuse this code many times. That's the importance of function usability. So it's not that anytime I want to do the square root of a number, I have to calculate the square root manually. I can just call a function that will do that for me, and to do that for me, easy as ABC. So this is just like this is just a very brief to get just a brief idea of what a function. Just like when in mathematics, when you say sine x, or you say cos x, all those things are functions. They are taking the sine of x, the cosine of x, the tangent of x. They are all functions. They take an input. They'll take the function will take the input. Function takes input, process it, and gives them outputs. And then we can always reuse that function in our code. So let us look at more implementations of simple functions. Let us implement the power function let us implement the power function. And the power function is if, for example, we want to take to the power of something. So want to do, for example, let's implement the power function. So I've chosen this one. Let us implement this power function. So before we start implementing, us the pseudocode. So I want to implement power function. So our power function, for example, 2 to the power 4 is to 2 times 2 times 2 times 2 in 4 times, which is 2 times 2, 4 times 2, which is so this is our power function. So this, for example, so we want to implement a function that we can take that, but if we put, for example, if we do power and we put 2 to 4, it will do 2 to the power 4 and to give us 16. Or we can do power 3 and 2, which is going to give us 3 times 3 is equals to 9. Or we can do power 5 to the power 3, which is going to be 5 times 5 times 5. It's 5 times 5 is 125, if I'm not mistaken. It's 125. As you can see, it's easier to write it this way. It's easier to write it this way and to write it this way. And so let us just look at a simple implementation of want to now implement so that we can get a very strong grasp of what the function is. So if we want to do a power function, we need them 2 arguments. The number and the exponent. Or the power. So, or the base and the exponent. So our function is going to have 2 arguments. So number is just the number I want to raise to the power of something, and the power there is what I raising to the power of. So 2 to the power of 5, for example. So 2 power 5. So is so this is how our function will be. So how will the actual code be now? So if we want to do something to the power of something, I want to multiply it by the exponent. That's number of times. So pseudocode, for example, for this one, so power number, I say 4. This is a for loop, 4 int So this is just a rough pseudocode of what you want to do. So all I'm saying, if this loop is what am I saying? So I'm saying for int I equals 1, int I less than equals to the exponent, so 5 plus. So what I just using that, so you will do, for example, if this is 2, we'll start with 2. 2 times 2 to give us 4. We have done that once, and we just keep looping until we get to this 5. I don't know whether you are having or should we implement a simpler function so that if we can get the idea. I don't know. I in this case is just a counter. I'm just using I. Or let us not implement it, but a path is it might come as let us implement a simple let us call it a simple division function. Let us implement the division function. I think this one most people are not really catching on. Let us implement the division function. So this is a pseudocode. So what this function will do is just to divide two numbers. Any two numbers will give it to divide them. So let's call this one division. Let's call this number division, function division. This division, we have the numerator and the denominator, right? The numerator and the divisor. Also dividing by. So let us just implement a simple division function. Let me don't do that part. I think most people are not really I'm trying to put too many concepts into one. So let us keep it very, very simple. So let us implement a simple division function. So this simple division function, you give it two numbers and to divide them. Give us the numerator, that's the number on top, and the divisor, the number on the bottom that will divide this by. So this kind of function, we will now say quotient or the result of division. Result of division is equal to numerator divided by it's just a simple division function. Simple to divide two numbers. That's in there. Result of division. So this is a simple division function. This is not an exact code. This is just like as a pseudocode. This is not an exact code. So that was also what we are doing. So who now can? We're missing one thing. We're missing one very important thing in this pseudocode. We're missing one important thing. I can't tell you what that is. I'm missing one thing. We have the function arguments. These are the arguments, the two arguments that you take. And this is the function name. This is the process. This is the return value. We're missing one thing now. And what is that? So I'm missing the return, the function type. What type is the result of division going to give us? Now, if you think about it, when we divide two numbers, what do you expect to get? So, for example, if you divide 10 by 2, you will get 5, right? Let's say we divide 10 divided by 2 is equals to 5. What about when you do something like 5 divided by 2? equals to 2.5, right? So now, what is going to be the best type? Should we use int in this case? Should we use int, or should we use another type? Keep in mind that should we use int or should we use another type? Because we should not use int. Do you know why? Because if you use int, for example, if you do 10 divided by 2 to give you 5, or if you do 5 divided by 2 and use integer, it will not give you 5. In computer science, 5 divided by 2 is actually 5 divided by 2 is equals to 2. It will ignore this 0.5. So ignore 0.5. You can go to your and type it and you see it. So we should not use int. We should use, in fact, we should use float to make sure that the computer will not ignore this decimal place. To make sure that the computer not ignore this decimal place. And then we can also use it as float. You can call it float. You can call it, does not matter. You can call it float. Call it float. But let's choose float. So we can call it float. This to ensure that the computer does not ignore the decimal. Let me just copy this thing and show you two quick examples for why you should be very careful with those sort of things. Let me just move all this. Now, somebody's asking whether we should use double or float. Yeah, right. Float is okay because it's just a matter of precision. For what we are doing, double will give you a 8-byte precision. 8 bytes is 64 bits precision, and float will give a 32 bits precision, or which is a 4-byte precision. Anyway, let us use float. I'll also show you something. I'm trying to just make this as this code can be better than this. This code is actually, if it's when I was still in when I was working, this code will not pass a code review. It's actually not very good code, but this is just for teaching purposes. So let us call this so float. So this is our function name, division. I don't like using just use small letters for this one. So use small letters. Does not matter, but I just like so division. This is the function name. These are the arguments. Our function can take more than 2 arguments. So, but for what we are doing, only needs 2 arguments: the numerator and the divisor. So the result of when we divide is the result of divisions. Let me just run this to make sure that everything is fine. So everything is fine. So now we have this is our function. This is our function division. So now we can call this function in our main program, and we can, apart from calling a function in the main program, you can also call a function in another function. But for now, let's just call this function our main program. Let us say division. Let's say 10 100 and then 5. 5.0. So print f, so we need to ensure that so I don't want to do a print f. So want to divide 100 by 5. So 100 in this case is the numerator, that's the number up, and it's the vice versa. So let us just run this. So oh, sorry, this should put the comma here. And do this again. Exactly, so good. As you can see, the computer has divided 105 and that's giving me 20.00000. So you can see you can use this function and we can just any points in our program now. You can call division. You can write maybe 1 million line of code. Let us say 100 million line of code. And we can still call this function at any point, division. I call it maybe 9 and 6. It does not matter where, so far we have defined this function in this code. As long as we have defined this function in this code, we can use it any point in this code, any point, no matter how long the code, you can just at any point, you can use it at any point in this code. So you can see is that is instead of doing a manual, instead of doing a manual division, we can just do divide 100 by those on this again. Okay, so I'd not add a new line. Let me add a new line. So this so you can see 6 over 9 give us 1.55, 1.5000, and this precision. So, but if you use a calculator, you see that 6 and 9 is 1.5. So I want to also try something. Let me say 0.7. 9 divided by 0.7. I just run that. Let's see. So once you have done, you have defined the function like this. We can use it at any point in our program. We can just call, instead of typing how everything, we can just call division and to just do what we have told it to do before, what we have defined for it to do at any point. We'll do what I have told it to do before. And this is how maybe I've been of libraries and framework in some of I've learned of different framework or different libraries. This is how libraries are written. The same thing. For example, this maths.h is a C maths library. I will encourage you to go to the C guide, C preference guide, and you look at the different functions that are defined in maths.h. There's the power function there. There's the square root function. There's the cosine, tan, and sine, or other different functions too are defined in this maths.h library. So for here now, I've done a simple division. I've just done a very simple division function. Now, there's something I want to show you. Yeah, I did float result of division is equals to numerator over divisor. I could have done something equal. I could have just done something like this instead of declaring a new this. I can just do this. I just do this. On this, I can say I've gotten rid of 2 lines. I can also return numerator over divisor and to still give me the exact same answer, nothing change. Nothing will change. I can also do that. But the reason I did it in the previous way, the reason I did it like this is to make my intentions clear, to make it more verbatim so that everybody can follow what is happening. That's why I did this like this. So here we have a variable, and that variable will hold the result of these two inside there, and then return that result for. If you don't put this return statement, it will give you an error. Let us say, for example, I do return it. Let us say I don't return this. I return 0. For example, that's why I return 1. Yeah, you see that I will not be able to guess my answer. I always get 1.0000 1.000 because I'm returning 1. I'm not returning the actual answer I'm supposed to get from this. So always ensure, don't forget, always ensure to return the result of what your function is. Always ensure to return the result of. It's very, very important. Even if you don't understand anything, just understand that 1, this is the function name, function type, the arguments. It must not be 2. It can be more than 2, depending on what the function is going to do. For here, we're just doing a simple division. That's why we're using only 2. If we're doing something more than maybe you want to multiply 4 numbers to have 4 arguments, so just simple division we're doing. So that is why it's only having 2 arguments. It's not that a must your function must have 2 arguments, and you should be careful the type. So yeah, you see that I've used float type. Float type allows me to have decimal places in my answer. If I just use int, for example, let's say I use int. Because of the way C is designed, C does not support automatic casting like C++ or Python. So I'll have to change all this to int also. I can leave them as float anyway. But I have to change this to int. If I do this and I run, you can see to return as return plain is showing me C here. So let me also change this to G. Change this to G. So I run again. Return result of division. Give me return result of division. Is my spelling wrong? Okay, so my spelling is wrong here. Sorry about that. So let me run this again. So you can see now is giving me garbage answer. You can see it's giving me a garbage answer for this one. It's telling me that 9 divided by 7 is 12, which is wrong. This one is okay because 105 that what's integers, but here I've done 0.7 is giving me garbage answer. So as I must be also be careful of what the type you are using. So that's the unlike say something like Python. Python will just do it automatically for you and to correct this for you, but in C you must make sure you correct it yourself. So this is back. We're wanting back to our correct answers. So you can see this is the answer we want, and not the previous answer is giving us. So that is the basic idea of what functions are. Functions allow us to reuse. Functions allow us to reuse. Functions allow us to reuse the same block of code instead of typing. So we use code and save typing. So we use code and save type. Let us look at one of our ALX projects that they gave to us, and let me show you guys something. Let us look at one of these projects that was given to us. Looking for one that we can just change to a function. Go to hello world. Let's go to hello world. Okay, I'm not seeing. I don't think I'm seeing what I'm looking for. I don't think I'm seeing what I'm looking for. I think I'm seeing what I'm looking for, but notwithstanding anyway, I hope everybody gets the idea of what a function is. A function just allows us to use a given block of code. A function allows so that's the importance of function, so that you can just always every time you type something out, you can just do a simple operation and do that. So most of people look at what is stack and heap. I was trying to talk about stack and heap today, but I think I don't want to rush us to one stack and heap, since I've also seen that we have not done pointers. I've not done pointers. So I think it's better we do pointers before we can now go to stack and this to avoid confusion about what is stack and what a heap is. So and why they're important in a function. So I think that would be that for now. As you can see, I still have my project I've not done, but please, if there's anything you don't understand, you can always hit us on the instead of you people chatting and spamming the whole WhatsApp group. It's for us to discuss, understand. If there's anything that's not clear to you, you can simply just ask anything that you don't get. Maybe all thing I've said that is not clear to you. Just ask this or this or I don't understand what this or what is this argument to? What is argument to? What is all these other things? And we will explain it to you. So before we go, we just let me just give some. If it's not just say it's not homework, it's not homework, it's not assignment. It's just to brush up your programming skills. If you are going to do the minimum required efforts, you will not go fast as software engineer. If it's only what they tell you to do that you are doing, if it's only what ALX say, oh yeah, do this that you are doing, you will not go. If you want to be a software engineer, you have to go the extra mile. You have to do more. You have to, because I'm telling you, the software engineering industry is very competitive. There are some people that have been coding since they were 10 years old, 9 years old. All these things that is just like beans to them. So most of them that are new to the thing, you have to work harder, you have to work more, you have to work harder, you have to work longer. So it's not just doing the minimum required effort, or the MRE, minimum required effort. No. It's not cut it, especially if you are doing C. You have to keep in mind, C is a very low level programming language. So you have to also do, so I'll just give us take home. As a simple take home. I'll just do take home. So take home one. For those that are interested, but please, before you are doing your take home, make sure to you have completed your ALX project also. So don't pennywise pound foolish. Don't do the important one. That doesn't mean you should not do more. So implement a function that then takes the number n of any length and sum its digits. If n is a single number, n is, so what I'm asking, if n is, for example, if n is 1, 2, 3, 4, answer will be 1 plus 2 plus 3 plus 4. 1 plus 2, 3, 3 plus 9, which is 10. If n is 1, 2.34, then you should do 1 plus 2, 1 plus 2 plus 2, 3, and 3 plus 4 to 7. So if you do this, it should sum them separately. And if n is 0, you just return 0, don't nice, n is 2. And if n is a single number, if n is, for example, 5, just return 5. So this, if you can, this function, I have to tell you, it seems simple, but it's very, 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 if you can do this, you have a very good idea on what functions, and I also have a very good idea on how to different between float, int, double, and the rest. You also have a good idea if you are able to. It's a very simple. I think I've just paste this. It's a very simple. It seems simple enough, but it's more difficult than you would think. I will have to tell you that I will not deceive you. It's very, very difficult. So very different. And with that, I think I will call it a class for today. And I'll hand over to my Oga. I think my Oga doubles.